It's the 2nd of September, 1859. The time is 9:30 a.m. In the telegraph office at 31st State Street, Boston, the operator's lines are overflowing with the current. Startled, they unplug the batteries connected to their machines and keep working using just the electricity coursing through the air. No need to pinch yourself, you heard that right. That night, the most bewitching auroras were recorded, breaking out across the skies of the earth. Puzzled eyes from Florida to Havana followed the auroras that shaded the sky a brilliant pink. The pinky clouds intermingled and deepened until the sky was painfully lurid. It looked like a fascinating scene from Harry Potter. No kidding. Auroras are enchanting, yet enigmatic. Not many are aware of the cosmological events that lead to a dazzling display of lights in an aurora. Are you one of those people? If so, watch on, for we are going to crack the mystery of auroras. We have to understand two things to know how auroras form the interaction and impact of solar wind on Earth. Second, Earth's protective mechanism against the solar wind. Let's start with solar wind. What is sunlight? Just another portion of the electromagnetic radiation given off by the sun. It is our primary source of light. But do you know what else the sun is sending our way? A planet-shattering wind. Sunlight is born at the very edge of the sun, a place called the corona. Nope, not the virus. This outer atmosphere of the sun extends many thousands of kilometers above the visible sun's surface. Corona's temperature exceeds 1,000,000 degrees, which makes it surprisingly hotter than the sun's surface temperature, only around 5,500 degrees Celsius. The material in the corona is a tenuous yet scorching plasma. This plasma in the corona gradually transforms into the solar wind that flows outward through our solar system. The solar wind is comprised of a mixture of materials found in the corona plasma. These include trace amounts of heavy ions and atomic nuclei such as carbon, nitrogen, oxygen, magnesium, iron, and sulfur. What if we told you that this solar wind impacts our Earth at a blasting speed of 400 kilometers per hour? It's only natural if you're a little freaked out. After all, it is a rain of charged particles directed towards Earth. So, what saves us? How is our Earth still alive and kicking? Why aren't we wiped out already like the poor dinos who had to face the wrath of fiery asteroids? Well, it is courtesy of the fact that our Earth is just one giant magnet. Again, don't pinch yourself just yet. It is composed of layers having different chemical compositions and different physical properties. The crust of the Earth has some permanent magnetization, and the Earth's core generates its magnetic field, sustaining the central part of the field at the surface. So don't be confused the next time someone tells you that. It is this magnetic field as well that deflects the solar wind up and away, saving us from the potential planet-wrecking solar winds. If it wasn't for this magnetic effect, we would have looked something like this. Not all of the solar wind is deflected successfully, though. Some of this wind manages to get to the Earth's poles, launching protons and electrons toward the Earth's surface. These highly charged particles collide with gas particles found in our atmosphere. This collision leads to an atomic excitation, causing the atoms to have more energy than they had before the collision. But just like the excitement of COVID holidays, it was short-lived. These atoms don't stay excited for too long either. The de-excitement happens when the gained energy is released in little light packages. We're just a few seconds away from understanding the myth behind auroras. When different atoms de-excite, they emit different light packages. For example, when an atom of oxygen is excited, it emits a tinge of green and red. Similarly, the excitement of nitrogen atoms can release a red-blue light that makes the sky glow purplish-pink sometimes. We see auroras mostly at night, but in reality, the excitation and de-excitation at the atmospheric level is happening all the time. Yep, every hour, every day, every month, all year. What is more, it is not happening just on Earth. One can witness this beautiful sight on Saturn and Jupiter too. Sometimes things even turn from beautiful to heavenly. A solar storm is one of these examples. Massive solar storms are known as coronal mass ejections, which can unleash huge waves of charged particles. These powerful storms are rare, but when they interact with Earth's magnetic field and hit the poles, boy oh boy, that's a sight to behold. When a solar storm impacts our Earth's magnetosphere, it deforms the Earth's magnetic field temporarily. This event changes the direction of compass needles and induces large electrical ground currents on Earth. It is called a geomagnetic storm. A solar storm can induce magnetic reconnection in Earth's magnetotail. It launches protons and electrons downward towards Earth's atmosphere, where they form the most amazing auroras. We have talked about how auroras appear on the Earth so far, but what about their view from space? Breathtaking, to say the least. Images captured by the International Space Station will make your day shine brighter. The station passes by Earth's north and south poles at least once in 90 minutes. This means that the astronauts can easily capture almost all the auroras happening on the Earth. While these astronauts are highly trained photographers, they do the job at great personal risk. Auroras are beautiful, but capturing them in space comes with the risk of radiation. NASA has lifetime radiation protocols for its space flyers to protect against the ill effects of radiation in the orbit. Some of these ill effects include conditions like cancer. So you guys in the spacesuits, we really value every second you're spending out there, all alone. Science has come a long way from Aristotle dubbing auroras as flames of burning gas, to us now being fully aware of the events that lead to their formation. But despite the reasons behind this stunning display of lights, one finds it hard to not be in awe of this captivating display of lights that has been going on in our skies for billions of years.